Okay, students, let's see that today we'll discuss about that carbonyl compounds and carboxylic acids, aldehydes, ketones, and carboxylic acids. Objective we'll discuss. Okay, let's see the first question. The first question is very easy, ma. Just is the property of dihalides, geminal dihalides and vicinal dihalides. See here two isomeric compounds A and B. Its molecular formula is C3H6Cl2. Okay, let it maybe A, and another compound the same molecular formula, that is also C3H6Cl2. This is B. Now treated with aqueous KOH. Aqueous KOH solution means it is a alcoholic KOH means nucleophilic elimination. Aqueous KOH means nucleophilic substitution reaction. It is the nucleophile is OH minus ions. Okay. Now the first one, A compound is forming propanaldehyde. Propanaldehyde is the product. Propanaldehyde. CH3, CH2, C double bond OH. The propanaldehyde. And B compound on produce acetone. CH3, C double bond O, CH3. Okay, what are A and B? They are asked. Now for this case, one intermediate will forms. Here aldehyde terminal CHO group is formed, means the two OH groups at terminal carbon, that is CH3, CH2, CH, OH and OH. One carbon, two OH groups are unstable. Loss of water molecule produce propanaldehyde, and corresponding dihalogen, the geminal dihalide, is the two chlorine atoms at end carbon. Now the A is CH3 bond CH2 bond CH Cl2. Okay, that is A compound, means third option is correct. Now the B compound is the two OH groups at middle carbon, CH3 OH and OH bond CH3. It is unstable, loss of water molecule and converted into acetone. Now these two chlorine atoms at middle, internal geminal dihalides. CH3. So now the answer is third option is correct. Okay, students, I hope you understood. It's very easy, ma. So two chlorine atoms are present at the given A and B compounds. A and B have the same molecular formulas. Okay, two chlorine atoms at one carbon treated with aqueous KOH, and final product is aldehyde. If aldehyde is the functional group is the terminal, that's why the two chlorine atoms should be present at terminal geminal dihalides. If the two chlorine atoms are in the middle, means non-terminal, then treated with aqueous KOH at one carbon, two OH groups will form geminal dihydroxides, diols, converted into ketone, or this is known as acetone. Okay, the resultant product B is this. Now A and B we have to identify. A is 1, 1 dichloropropane and B is 2, 2 dichloropropane. Both molecular formulas are same. Now let's see the second question, dear students. It's very easy and very important also. Among the following reactions, in which reaction forms new carbon carbon bond formation. New carbon carbon bond formation we have to identify. Okay, first let's see the first option, Cannizzaro reaction. Cannizzaro reaction. Okay, students, what is Cannizzaro reaction, dear students? Without alpha hydrogens containing aldehydes. Means absence of alpha hydrogen atoms means formaldehyde. 2 moles of formaldehyde we need to take. HC double bond OH. Or benzaldehyde also it is possible. There is no alpha hydrogen atoms. Okay, students. So without alpha hydrogens containing aldehydes treated with base, in the presence of base, in the presence of base, base means either NaOH or KOH, NaOH or KOH, and produce one aldehyde group converted into oxidation. Another aldehyde group is undergoes reduction to produce alcohol and aldehydes. Sorry, alcohol and carboxylic acids. CH3OH and HC double bond O minus. If sodium hydroxide is used, it means sodium salts of carboxylic acid will form. In the same way, benzaldehyde involving in Cannizzaro reaction, the products are benzyl alcohol, CH2OH, and another one is benzoic acid, sodium salts of benzoic acid or potassium salts of benzoic acid. Okay, is treated with NaOH. See here in the two products there is no carbon carbon bond. New carbon carbon bond is not formed in the Cannizzaro reaction. Let's see Rosenmund reduction. Rosenmund reduction. What is Rosenmund reduction, dear students? All acyl chlorides or C double bond OCl or C6H5 C double bond OCl, benzoyl chloride. Acyl chlorides upon reduction in the presence of Lindar's catalyst. What is Lindar's catalyst, dear students? Palladium, barium sulfate in the presence of quinoline. In the presence of quinoline, that acyl chloride is C double bond O Cl group is converted into aldehydes or C double bond OH. Okay, this benzyl chloride is converted into benzaldehyde. See this chlorine place, what it will came, dear students? Hydrogen atom came. This there is no carbon new bond. Carbon new bond is not formed in Rosenmund reduction as well as in Cannizzaro reaction. Next, the third one is Clemmensen reduction reaction. What is Clemmensen reduction reaction or Wolff-Kishner reduction reaction, dear students? Clemmensen reduction reaction. Okay, in Clemmensen reduction reaction, C double bond O group, carbonyl group. Okay, C double bond O group. What is the Clemmensen reducing agent, dear students? Zinc amalgam HCl. Zinc amalgam HCl. So what is the difference between Clemmensen reduction reaction and Wolff-Kishner reduction reaction? The Clemmensen reduction reaction, the reducing agent is zinc amalgam HCl, means the reduction is taking place in acidic medium. Any acid level groups are present, they will be effects. Acid level groups means ethers, epoxides, those groups are called acid level groups. Wolff-Kishner reduction reaction means what, dear students? Hydrogen base, means the reduction is taking place in basic medium. It does not affect the acid level groups. That is very, very important concept for JEE and NEET examination. Now the Clemmensen reducing agent, the C double bond O group is converted into CH2, means hydrocarbons, alkanes. Here also just the C double bond O group is converted into CH2, but there is no new carbon-carbon bond formation. Now the fourth option is your answer, that is Raymond-Taman reaction. Already this Raymond-Taman reaction, yesterday also we have discussed that is in alcohols, phenol ethers. These phenol chemical properties there we discussed. Raman-Taman reaction. What is Raman-Taman reaction, dear students? The Raman-Taman reaction is phenol reacts with chloroform. If carbon tetrachloride you are used, then we'll get orthohydroxy benzoic acid, salicylic acid. Chloroform we are used, then we are getting orthohydroxy benzaldehyde or salicylaldehyde. Followed by hydrolysis, we are getting OH group as it is at ortho position. C double bond OH is formed. So the new carbon-carbon bond is formed. This is new CC bond. New CC bond. So your answer is Raman-Taman reaction. Just actually I need to say directly answer, but I gave the total information related to 4 options. Then we'll get a clear idea. And also here we are learned 4 different types of questions or 4 different types of named reactions also we are learned. So that's why I'm giving more information for every question. Then I'm taking more time also. Okay, but you have to solve more and more questions. You have to revise the concept more and more times. Then only we can solve the organic chemistry questions very easily. Okay, students. And very important also, do you want really crack NEET and JEE examination? Organic chemistry is very important. It is a key point. Who are doing the questions more, who are scoring more marks from organic chemistry without confusing, without going more negative marks, they will get good rank, they will get good score in JEE and NEET examination. It is very clear and no doubt at all also. Let's see the third question. Acetone enol form, CH3C double bond OH. Acetone, this is keto form. Keto-enol tautomerism. What is keto-enol tautomerism, dear students? Keto-enol tautomerism is nothing but the one proton is, the hydrogen atom is shifted from sp3 carbon to carbonyl group, and the hydrogen is shifted from OH group to adjacent sp2 carbon is known as keto-enol tautomerism. Always keto forms are more stable when compared to enol forms. Okay. And CH3 here, how many active hydrogens are present? These are alpha carbons. This alpha carbon, this is also alpha dash carbon. So this total 3 hydrogen atoms are present, and here 3 hydrogen atoms are present. The total 6 alpha hydrogens. 6 alpha hydrogens or active hydrogens are present. Active hydrogen atoms. This enol form is unstable. This enol form is treated with heavy water, D2O. D2O means D plus OD minus. This is also known as isotope, heavy water. Heavy water is the D means deuterium is the isotope of hydrogen. Now this will be cleavage to produce CH2 double bond COD bond CH3. Again this enol is unstable. Again converted into CdH2 C double bond O CH3. Again this undergoes keto-enol tautomerism to form CDH double bond COH bond CH3. This is treated with heavy water. Again form CDH bond double bond COD bond CH3. Again this enol is unstable and rearrange to gives CD2 C double bond O CH3. This process will be repeats. Finally all active hydrogen atoms are replaced by deuterium atoms. We are getting CD3 C double bond O CD3 deuterated acetone. Deuterated acetone is the product. So the enol is treated with heavy water. All the active hydrogen atoms are replaced by the deuterium. Then the final product is CD3, C double bond O, CD3. So your answer is fourth option. Okay, students, understood? Let's see the next question. Fourth one is very important. The reactivity, nucleophilic addition reactions, reactivity order of aldehydes and ketones. It's very clear. We are discussed also in regular classes. The fourth question, nucleophilic carbonyl compounds involved in nucleophilic addition reactions. Carbonyl compounds involved in nucleophilic addition reactions. Nucleophilic addition reactions. Okay, students. Now, the nucleophilic addition reactions, reactivity or nucleophilic addition reactions, rate or reactivity rate. Reactions rate is directly proportional to electron withdrawing groups or minus psi groups and is inversely proportional to plus psi groups. Inversely proportional to plus psi groups. Why, dear students? For example, C double bond O group, okay, then is converted into O minus and plus. Carbonyl group means we have to generate for to generate positive charge at carbonyl carbon. Positive charge at carbonyl carbon. So for generation of positive charge at carbonyl carbon is only in the presence of electron withdrawing groups only, but not electron donating groups. That's why the nucleophilic addition reactions of carbonyl compounds, the rate is directly proportional to electron withdrawing groups and is inversely proportional to electron donating groups. Therefore, aldehydes, aliphatic aldehydes are more reactive than ketones, and then aromatic aldehydes and then aromatic ketones. It's very important, dear students. Why aromatic aldehydes are less reactive or aromatic carbonyl compounds are less reactive when compared to aliphatic aldehydes? Because in aromatic aldehydes they involved in resonance. In resonance. So due to the resonance, their nucleophilic addition reactions rate is decreasing when compared to aliphatic carbonyl compounds. Okay, let's see the given question. Formaldehyde, HC double bond O H, and another one is acetaldehyde, CH3 C double bond O H, and another one is benzaldehyde. It's very clear, dear students. Aliphatic aldehydes. Benzaldehyde is aromatic. It is very less reactive. Now we have to compare that. These hydrogen atoms. Here it is a CH3 group. Is more electron donating group. Plus psi order for CH3 is more when compared to hydrogen atoms. That's why this formaldehyde is more reactive when compared to acetaldehyde and then benzaldehyde. So the answer is 1 is more than 2 and then 3. Fourth option is very clear. Okay. In the same way, some other important orders also we need to remember. The main important criteria, nucleophilic addition reactions of carbonyl compounds is directly proportional to electron withdrawing groups and inversely proportional to electron donating groups. Based on that, aldehydes are more reactive than ketones, and then aromatic aldehydes and then aromatic ketones. For example, only aromatic aldehydes they gave. Among that, they have some substance. In that substance, electron withdrawing group substance is present. It is more reactive towards nucleophilic addition reactions when compared to electron donating group. That kind of questions also we have to observe. For example, let's see, I gave one important example. We have aromatic aldehyde, benzaldehyde is present. That benzaldehyde has one substance, that is NH4 plus. This NH4 plus is strong electron withdrawing group, minus I group. That's why it is more reactive towards nucleophilic addition reactions when compared to CHO, when compared to NO2 group is present. NO2 is also minus I group. Okay. Then, but NH4 plus is strong electron withdrawing group when compared to NO2. Next one is benzaldehyde. And another one is para amino benzaldehyde. NH2 group is present. NH2 group is electron donating group, plus I group, or plus R group, electron donating group. Okay. Due to that electron donating group means it increases the resonance structures. That's why it is less reactive towards nucleophilic addition reactions. So like this kind of questions also they are asking. Okay, students, let's see the fifth question. Fifth question is very easy. Fifth question. What is the fifth question, dear students? A is treated with chlorine, produce CCl3CHO. On treated with sodium hydroxide, and what is the product and what is A and B they are asked. Now it's very clear. CCl3 C double bond OH is treated with base. Base means it is the product is this bond which we break. The product is CHCl3 means chloroform plus HC double bond O Na, sodium salts of carboxylic acid. It is nothing but chloroform reaction or haloform test. The haloform test, the starting material. How can we produce this compound, dear students? This functional group is as it is. Now we have to here CH3 group. This CH3 group is treated with chlorine. Means 3 moles of chlorine, loss of 3 HCl. We are getting chloral. Trichloroacetaldehyde is known as a chloral. Okay, now the A is acetaldehyde. This is the B, the major product is chloroform. Now the answer is CH3CHO and CHCl3. So the first option is correct. It is the application of haloform test. In haloform test, chloroform it is formed, then it is called chloroform. If it is a bromoform, CHBr3 is formed, it is known as bromoform test. CHI3 is formed, it is known as a iodoform test. These tests also we are discussed in alcohol phenol ethers, because under special conditions exceptions are there for haloform test. Ethyl alcohol and terminal secondary alcohols gives positive haloform test, as well as methyl ketone compounds. Okay, students, let's see the sixth question. The sixth question, what is B? The conversion from A to B, what is B they are asked. First, let's see that it's very easy. Toluene is treated with CrO2Cl2. by carbon disulfide CrO2Cl2 followed by hydrolysis in acidic medium is known as Itard's reaction. Okay, and chromyl chloride, this is known as Itard reagent. Itard reagent, chromyl chloride. Then what we'll get, dear students? The product is benzaldehyde will get. Okay, now this benzaldehyde is treated with base in the presence of base, means is nothing but Cannizzaro reaction. In the Cannizzaro reaction, what are the major products, dear students? One is benzyl alcohol and another one is sodium benzoate or benzoate ion. Okay, now let's see that given options from A to B, the conversion is this A to B, the formation of A to B. This is B product. This reaction is known as Cannizzaro reaction. Okay, so your answer is first option. Okay, let's go for seventh question. A substance A, a substance molecular formula C4H8O. This is A, dear students. This is on oxidation. This is on oxidation. We are getting the product is C4H. Sorry. C4H10O. This compound is A. This is on oxidation. We are getting C4H8O. Okay, it gives oxime. Is treated with hydroxylamine NH2OH, forms oxime. Forms oxime means what it indicates, this reaction? This reaction indicates it has carbonyl compound. So the B, this let it be B. B is a carbonyl compound. Carbonyl compound. Okay, and B is also treated with iodoform test, positive iodoform test. Iodoform test. Positive iodoform test means the B must carbonyl group. B is methyl terminal or methyl ketone. B is methyl ketone. So what is B, dear students? Now we will get idea. 4 carbons containing methyl ketone means CH3, CH2, C double bond O, CH3. This then only it is forms iodoform test means what are the possible products? CHI3 plus CH3, CH2, C double bond O, Na. Like salt will forms. Okay, now another important hint also they gave. This A is treated with concentrated H2SO4, loss of water molecule and produce C4H8 alkene. Alkene is the formed. So what is this A? A must should be, so based on the conversions, A must should be terminal secondary alcohol. Terminal secondary alcohol, that is CH3, CH2, CH, OH bond CH3. Then only is on oxidation we are getting butane 2-one. This can form iodoform test. and is treated with hydroxylamine, forms oxime. What is that oxime formula, dear students? NOH. Here CH3 group is present and here CH2, CH3. Like this is oxime and is on treated with concentrated H2SO4, loss of water molecule and produce CH3, CH, double bond CH, bond CH3 according to Sergic rule. Serjoff rule, but2 is the major product and but1 also forms. So both molecular formulas is C4H8 only. C4H8 only. So your answer is second option CH3 CHOH bond CH2 CH3. Okay, the A is butane 2-ol. A is butane 2-ol. Its molecular formula C4H10O. C4H10O. Okay, students. Let's see the next question. Eighth question, dear students. It's very easy. Among the following, which has most acidic hydrogen atoms? Which has more acidic hydrogen atoms or most acidic hydrogen atoms, dear students? The hydrogen atoms which are bonded with 2 electron withdrawing groups, then those hydrogen atoms are considered as more acidic hydrogen atoms. The first option C, cyclohexanone. 1, 2, 3, 4, 5, 6, 3 is only one C double bond O group is present. So it contains, these are acidic hydrogens. Star mark at it, these CH2 groups. And second one is hexane 2,4 dione. 1, 2, 3, 4, 5, 6. Here second and fourth double bond is present. If you observe that these groups, the C double bond O group and this C double bond O group are minus I groups, electron withdrawing groups. The middle CH2 group, this CH2, here the hydrogen atoms are more acidic hydrogen atoms when compared to remaining all options. Let's see the third one, hexane 2,5 dione. 2, 3, 4, 5. So 2,5 dione means here this C double bond O groups are separated by large distance. That's why the middle these CH2 groups are acidic hydrogen only. When compared that second option, less acidic hydrogens only. When compared to first option, when compared to first option, more acidic. When compared to second option, less acidic. Now the fourth one, here 2, 3. 1, 2, 3, 4, 5, 6. The C double bond O groups are adjacent only. Automatically the strength right side and left side hydrogen atoms are acidic, but the effectivity of acidic hydrogens is very less when compared to second one. So the second compound, what is the second compound, dear students? Hexane 2,4 dione contains more acidic hydrogen atoms when compared to the remaining 1, 3, 4 options. Next, what are the products formed when the cross Cannizzaro reaction they get? See the cross Cannizzaro reaction, benzaldehyde and formaldehyde. Always aromatic aldehyde, benzaldehyde is reduced to gives alcohols, primary alcohol, it oxidized. Formaldehyde oxidized to gives acid. So now the products are benzyl alcohol and formic acid, C double bond OH, because followed by hydrolysis, treated with base followed by hydrolysis, benzoic acid. Now the answer is fourth option. Fourth option is correct. Benzyl alcohol and formic acid. Okay, students. Let's see for 10th question. 10th question is nothing but